Okay, in this problem we're going to find g composed of f of x, f composed of g of x, and h composed of f, and we're also going to find the domains of those composed functions. So let's start with g composed of f right here. So g composed of f of x means g of the function f of x. So f is the input to the function g. So we work our way from the inside out. So we start by plugging in f of x here. So we have g of the whole function f of x, which is the square root of x plus 3. So the root of x plus 3 is the input to the function g. So we would replace that x by root of x plus 3. So we'll have 2 times the square root of x plus 3 plus 7. Now the domain of this composed function can be no greater than the domain of g or the domain of the combined function. So the domain of g right here, oh no, f, because f was our input. The domain of this function f right here is that x plus 3 has to be greater than 0. Put that over here, has to be greater than 0. And so, if you subtract 3 from both sides, you get that x has to be greater than or equal to negative 3. That's the domain of this function f. The domains of g and h are all real numbers because they are polynomials. So the domain of this combined function, because we have a square root of x plus 3, is that x has to be greater than or equal to negative 3. Then for f composed of g, make sure you pause this video and try this one on your own first. Okay, for f composed of g, we're going to plug g of x into the function f. G of x is the function 2x plus 7. So we're going to take f of 2x plus 7. So I'm going to replace this x by 2x plus 7. So we'll get the square root of 2x plus 7 plus 3. So I replace that x by this whole input, 2x plus 7. Simplifying, that comes to the square root of 2x plus 10. Now the domain of g still has to apply, so we already know that, well, the domain of g is all real numbers, so actually there's no restriction there. Instead, we need to focus on the fact that what is under this radical has to be greater than or equal to 0. So for this domain, 2x plus 10 has to be greater than or equal to 0. Solving this for x, we get that 2x must be greater than or equal to negative 10, and x must be greater than or equal to negative 5 when we divide by 2. So that's the domain of this combined function. And then lastly, we're going to find h composed of f. So h composed of f of x means h of the function f of x, which is the square root of x plus 3. So we're going to plug that entire expression in for x over here on h. So plugging that in, we replace this x by root of x plus 3, and that is being squared, and then we have a minus 1. Now this is the unsimplified version of the composed function, and I recommend that you find the domain at this step before you simplify, because when you simplify, the square root and the square cancel, so you have x plus 3 minus 1 or x plus 2. However, you are restricted here. You cannot plug in an x into this combined function that is less than negative 3 because you would have a negative under that radical. So the domain of this is that x still has to be greater than or equal to negative 3 because that's the domain of f, the function that you are putting on the inside. Okay, and that's the domain at this unsimplified step. And last, we're going to express this given function as a composition of two functions f and g. So capital H of x is defined as x squared minus 3 all to the 5th. The goal is to find two functions f and g so that when you compose them, f composed of g, this is what you get. Okay, so this is a bit of a guess and a check, but essentially g right here is like your inside function, and f is what you do to that. That's like your outside function. Okay, so a good guess here is to let g of x be the inside part, which is x squared minus 3. And f of x is what you do to that. Well, what you do to that x squared minus 3 is you raise it to the 5th power. So the outer function would be x to the 5th. Now that's a guess. So now let's check. Let's actually compute f composed of g of x and see what we get. When we write f composed of g, that means f of the function g of x, or f of x squared minus 3. If we take f of x squared minus 3, we replace this x by the entire expression, x squared minus 3, so we do get x squared minus 3 to the 5th. So it does work, and those are two functions who, when you compose them, you get this expression. So the idea is to let g be the inside function and let f be the outer function, or what you do to that. And when you describe f, you put an x in place of wherever your g is. If you have a fraction or a rational expression, often you would let the denominator be the inside function. For example, if you had 2 over x minus 8, it doesn't exactly appear like a composition of functions here, but a nice little trick that will work is to let your inside function be the denominator. Not always, but oftentimes that will work. And then let your outer function be what you do to that. Well, what you do is you do 2 divided by g, so your outer function would be 2 over x. And that's it for this video.